Welcome. This video is an introduction to graphing, and in this video we'll be going over how to label a graph, how to plot points, how to determine if an ordered pair is a solution to an equation, how to find x and y intercepts of an equation that is ax plus by equals c, as well as nonlinear forms, how to graph equations, and how to find distance as well as midpoint. What is a graph? A graph is a diagram that shows the relationship between variable quantities, and this is typically two variables, x and y. One thing that you need to know is what is the origin, and this is the point 0, 0, and it is the easiest thing to find. It's where your two axes meet, and your x-axis is your horizontal axis or your horizontal line. Your y-axis is your vertical axis or your vertical line. An ordered pair is a pair marked xy. X always comes first and y always comes second. An example would be 5, 4. And here's an example of where it would go. And you also need to know quadrants. They go counterclockwise. So we have 1, 2, 3, and 4. Quadrant 1 has both x and y positive, positive. Quadrant 2, your x's are negative and y's are positive. Quadrant 3, both x and y's are negative. And quadrant 4, x's are positive and y's are negative. How do you plot a point? Remember that x's always come first and y's come second. And x is also known as abscissa and y is known as an ordinate. This is a fun fact. So you have your point 0, 0, and this should be the easiest thing. It's right in the middle where your two axes meet. Point B is negative 3, 5, which means we will be going to the left 3 and up 5. We'll be in quadrant 2. C is 4, 3, which means we'll be going to the right 4 and up 3, and we'll be in quadrant 1. For point D, you need to make sure that you remember that x's always come first and y's come second. So this is a similar point, you just have 3, 4 instead, which means we'll be going to the right 3 and up 4, and we're still in quadrant 1 in a different spot. For point E, we have 3, negative 4, which means we'll be going to the right 3 and down 4 instead of up 4. So we'll be in quadrant 4. For point F, we have two negatives now, negative 4 and negative 2, which means we'll be going to the left 4 and down 2. We'll be in quadrant 3 for point F. For point G, the point 0, 4, we will be neither going left or right any units, but we'll be going up 4. So it's right on your y-axis. For point H, we'll be going left 3 units, but we'll not be going up or down because your y is 0. So we'll be right on the x-axis for point H. Solutions for equations typically have two variables. This would be x and y, and these solutions appear on the line as a coordinate pair, x and y. If you are given one variable, if you're given x, then you'll substitute that number for x, and then you can find y. Or if you're given one variable for y, then you'll substitute that variable for y and solve for x. Or you may be given both coordinates, and you can substitute both and find if that solution is true. So here we have a line 2x plus 3y equals 18, and we needed to determine if this point, negative 5, 4, is a point on this line. So we can plug in negative 5 for x and 4 for y, and this gives us 2 times negative 5 plus 3 times 4 equals 18. Following order of operations, we find that 2 equals 18. This is a false statement, which means that this point is not on the line and it is not a solution to this equation. Now we will try the point 6, 2. So we will plug in 6 for x and 2 for y and find that 18 equals 18. This statement is true, which means this point is on this line and it is an equation, a solution to this equation. How do we find x and y intercepts? So an x-intercept is when a graph crosses the x-axis at point some number for x and 0 for y. A y-intercept is when a graph crosses the y-axis at point 0, y. So we need to find the x and y intercepts for this equation, 2x minus 4y equals 8. If we know to find the x-intercept, we need to plug in 0 for y. And then we can solve for x. So 2x minus 4 times 0 equals 8. And if we solve for x, we'll find that x equals 4, which means that our x-intercept is the point 4, 0. We can do this again for our y-intercept. So to find the y-intercept, we'll plug in 0 for x instead of y. So we have 2 times 0 minus 4y equals 8. So 0 minus 4y equals 8. And to solve for y, we'll divide by 4, and we find that y equals negative 2. Our y-intercept is 0, negative 2. How do we graph this equation? So we need to draw the points that represent the solutions for the equation. We found the points 4, 0 and 0, negative 2. But we also need to find a third point to make sure that these intercepts make sense. So we'll first plot 4, 0 and 0, negative 2. And we know that we can use 2 for x because it is in between those 2 points, and then we can solve for y. And if we solve using that coordinate pair, we'll find that the coordinate 2, negative 1 is in between those 2 intercepts, and that does make a straight line. So these intercepts do make sense. This is a straight line, making this a linear equation. We need to find the x and y intercepts of this equation, y equals x squared plus 4x minus 5. But first we would factor into binomials. And the two binomials would be x minus 1 and x plus 5. And if we set those equal to 0, x minus 1 equals 0 and x plus 5 equals 0, we'll find that x equals 1 and x can also equal negative 5, making these our intercepts, point 1, 0 and negative 5, 0. So we need to recognize that this equation is not linear and we cannot draw a line straight from these 2 points. We can use any other point between these 2 points. So negative 4 for x, negative 3 for x, negative 2 for x, negative 1 for x, 0 for x, 2 for x, just so we can find the general shape of this graph. When we plug in these x values, we'll find corresponding y values. So instead of just negative 4, we'll have a coordinate pair negative 4, negative 5, and then negative 3, negative 8, negative 2, negative 9, negative 1, negative 8. So we see our graph is turning. Then we also have 0, negative 5, and 2, 7. So our graph is exponentially reaching upward. So our graph is a parabola, not linear. This is the distance formula. You can use it for any 2 points, x, y, and x sub 2, y sub 2. And distance is the square root of your changes in x squared plus your changes in y squared. So let's say you have this line with one point, negative 3, 2, and another point, 4, negative 5. So you would plug in your x's together. So you have negative 3 minus 4 squared plus your y's together, 2 minus negative 5 squared. And this gives you negative 7 squared plus 7 squared. And you would have to take the square root of 49 plus 49, which is the square root of 98, and you can simplify that to 7 root 2 or 9.8995, as close as you can get it. So this is your distance for these 2 points. A note, you can switch your x sub 2 and x sub 1 and y sub 2 and y sub 1, as long as you're consistent with it. You can't just switch x's and y's willy-nilly. So here we have 4 minus negative 3 instead of negative 3 minus 4, and now you have negative 5 minus 2 instead of 2 minus negative 5. You'll still get 7 root 2 or 9.8. And this is the distance between this line. This is your midpoint formula. It's used to find the middle point or average between a segment. So you find the average of your x's divided by 2 and the average of your y's. So here you have a line with point -4, -4, and another point 2, 4. You'll add your y's together and your x's together. So first, your x's, -4 plus 2, and then your y's, -4 plus 4. So -4 plus 2 divided by 2 for your x gives you -2 divided by 2, and for your y's you have -4 plus 4 divided by 2, which gives you 0 divided by 2. Your midpoint would be -1, 0. And this is an accurate solution. It is the middle point for your line. Another note, you can switch your x's and y's just like your distance formula, as long as you are consistent with it. So instead of -4 plus 2, now you have 2 plus a -4. Instead of -4 plus 4, you have 4 plus a -4. But you will still get the same answer of -1, 0 for your midpoint. Thank you, and that is all for this video.